Hello and good day. In Geometry Gold, we're covering PO7, which is identifying complementary, supplementary, and linear pair angles. Turns out that complementary and supplementary angles are a bit of review. So now, share your wisdom with me. What are complementary angles? Complementary with an E, not an I, right? They're not like nice angles, but complementary.
Angles that add up to be 90 degrees.
How many angles add up to 90 degrees? Is there a restriction to how many there can be, Alan? Two, right? So complementary angles are two. Oh, did I forget to put this on? I did. Oh, smart. Okay, two angles that add to be 90 degrees. Two angles that add to be 90 degrees. How about supplementary angles? Supplementary, Lucas.
Two angles that add to be 180.
Good. Two angles that add to be 180 degrees. You will quickly find that there are essentially three numbers that you need to become very familiar with in geometry. One is 90, the other is 180, and the third is, any guesses? 360. If you can add and subtract and multiply and divide to those three numbers, that's about half of what geometry is, right? Because 90 degrees, we talk about right triangles, right angles, 180 degrees. We've got linear pairs that make a straight line. Triangles, their angle measures all up to be 180. And what's significant about 360? What shapes are very 360-ish? Circles and squares, rectangles, trapezoids, any four-sided shape. So those are kind of the three pillar numbers of geometry. Adjacent angles. What does the word adjacent mean? Olivia and Audrey are adjacent at this point in time.
Angles next.
Right. The word adjacent means next to. So adjacent angles are angles that are next to each other, but more specifically, angles that share a side. That's what's going to make angles next to each other. Angles that share a side. So if you've got angles such as this, okay, right? You've got angle 1 and angle 2. The side that those two angles share is this one. You know, that's part of both angle 1 and angle 2. Angle 1 and 2 would be considered adjacent angles. Angles do not need to be adjacent in order to be complementary or supplementary, though. If you have I'll use blue. I haven't used blue in a while. If you have a 30-degree angle sitting over here and down away from it, you've got a 60-degree angle, they can still be complementary angles, even though they are not touching. Okay? So angles do not need to be adjacent. So in the diagram below here, a little bit of chance to practice with four angle terms that we've talked about: complementary, supplementary, going back a little bit, vertical angles, and a linear pair. Given that the measure of angle 2 is 90 degrees, so let's go ahead and draw that right angle box in there for angle 2. Okay? And that angle 3 is 45 degrees. Give an example of complementary, supplementary, vertical angles, or a linear pair. Any ideas? You can tackle any of those four. Audrey.
3 and 4 would be complementary angles.
How do you know that the sum of 3 and 4 is 90 degrees?
Because 3 is 45 degrees, and like 2 is like it's a vertical angle with like 4 and 3. So you know that it's going to add up to 90.
Well, 2 is actually a vertical angle with 5, because those are opposite. But you are correct, because 2, 3, and 4. What do 2, 3, and 4 make? 2, 3, and 4 together make a line, right? You know, if you take angles 2, 3, and 4 together, they make that vertical line, kind of verticalish. So if we know that 2 is 90, then 3 and 4 have to add to be 90 to make that straight angle measure of 180. Okay? So yes, 3 and 4 would be complementary angles. And before you say, you know, well, wait, if 3 and 4 are both 45, that means they're congruent. They certainly don't look congruent. This is where you run into the whole, you know, trust the math, trust what you're given. Don't focus so much on how the diagram looks. Okay? All right, complementary 3 and 4. Supplementary angles. What's an example of supplementary? Yes, Olivia.
2, 3, and 4.
Well, remember, supplementary angles can only be a pair of 2.
Oh, okay, then 2 and 5.
2 and 5, yes. 2 and 5 are both 90. So they will sum to be 180. And we can also put 2 and 5 where? They have another relationship as well. Alan? Vertical angles. Just for kicks, what's another pair of vertical angles other than 2 and 5 that we have here? Just for a little bit of variety. Yeah. 1 and 4 would be another option. They are opposite each other at that vertex. What else do we have? What's the third pair? 3 and 6. Okay. The last thing I ask you is for a linear pair. Do you see a linear pair in the diagram? You can flip back to CO6 for the definition of a linear pair. But like I talked about before, you can kind of oftentimes look at the word linear, line, pair, 2. So we're looking for 2 angles that make a line. Julia.
Angles 3 and 5.
3 and 5 are part of a line. We kind of look at this line coming down like this, okay? 3 and 5 help make that line, but so does angle 4, right? So 3 and 5 would not be just 2 angles that make that line. Yeah.
Would it be angles 1 and 2?
1 and 2, same situation. I mean, angles 1 and 2 here, they don't quite make it a full line. Angle 6 would also be part of that, or angle 3 for that full 180-degree line. I should teach this lesson on either Halloween or April Fools because it's a trick. There is not a linear pair example in this particular diagram. There are no 2 angles that make a line.
Well, you definitely tricked us.
Sorry. I feel kind of bad. I mean, I'll be over it right now, but, you know, for that brief moment. It was, yeah. Okay, questions on that? No. Moving on then. Here's where we get to practice some of these relationships a little bit more. Okay. Tell me what you know about 18x minus 9 and 14x plus 13 that's going to help us solve for x and figure out what those angle measures are. What is their relationship? What do you know about them? And these 3 here are what your con assignments are for this coming week. Okay, so this is going to be good practice. You'll be able to practice again right away if you spend your Friday night doing con, because who doesn't want to do con on a Friday night? Yeah.
They're gonna add up to 180.
And how do you know that?
'Cause
What do angles DEG and GEF make? They make a line. They are a linear pair. Here's an example of a true linear pair, 2 angles that make a line. And if we're dealing with a linear pair, we know that the sum of those angles, 18x minus 9 plus 4x plus 13, have to equal 180. There's your relationship, right? And now you go about, you combine like terms. You know, you've got 18x's and positive 4x's. Total, that's 22x's. You've got negative 9 and positive 13. They combine to make positive 4. So you have 22x plus 4 equals 180, and now you can do your railroad tracks, opposite operations, whatever you want to call it, to get x by itself and solve. Right? But it goes back to recognizing that initial relationship that these two angles will sum to be 90. Or sorry, 180. I'm looking at the next one. The next one, what do we know about 6x and 4x? DEG and GEF again. Julia. They form a right angle, right? Because DEH here, that right angle box is marked there. So we know that the other two angles, the other half of that has to be 90, so that adds to 180. So the relationship we can write, 6x plus 4x equals 90. Right? 6x plus 4x equals 90. In the blue group, the equation they came up with was 90 plus 6x plus 4x equals 180. Right? They included that given right angle. These two things are the same though, right? Because as soon as you subtract 90 from both sides to, start to get x by itself, here it cancels out, and 180 minus 90 is 90. So if you understand that, you can kind of skip that first step there, but either way it works. And that's your relationship to solve for x. How about the last one? What can we set up there? We've got two variables. Let's take a look at x. I'm going to apologize in advance here, but what relationship can we set up using the angles with x? Are they vertical? Are they a linear pair? Are they complementary? What do you see? Julia? They're adjacent angles. They do share that side, right? We got 4x minus 100 and x plus 5. So they do share that angle side. And what do those two angles make? 180, because they make a line, right? The line that they make comes right down through here, right? So what we can say is that 4x minus 100 plus x plus 5 equals 180. A very similar situation to what we have over in the first one. It's just our line they make isn't, going directly horizontal. It's kind of diagonal, but they do still make that line. Combine like terms. 4x and x give us 5x. Negative 100 and positive 5 give us negative 95. And together they equal 180. This one I would like to solve the rest of the way. So when you get the value for x, raise your hand and share it with the rest of us. 5x minus 95 equals 180. What is the value of x? Lucas?
I get 55.
It's not what I got.
Correct. Oh.
I apologize in advance. I did. Julia? Thanks for playing. Yes. Okay. X equals 55. Whew. Emotional. Which means that, we can solve for those angles with that value. 55 plus 5 is 60. 4 times 55 minus 100 is 120, which is good news for us because what's the sum of 120 and 60? 180, exactly what it should be, right? If we'd solved for x incorrectly and plugged that in here, and we got, something like 110 and 50, well, that's not 180. We know that would not be right because it has to work. Now that we've got x, give me two things we could do to to solve for y? What are two relationships we could set up to solve for y here? Audrey.
You could do 2y plus 3y plus 30 equals 180.
Okay. We also see that our y angles there, they also make a line, just like the x angles did. So their sum will also be 180. So 2y plus 3y plus 30, the sum of those angles, will equal 180. We could have done that first, right? If we had chosen to solve for y first, that's what we would have set up. But now that we know what x is, and we filled in two of these angle measures, what else could we do? Alex?
We know that 2y and x plus 5 are vertical angles. So
Yes.
we can just fill in 60.
Right. It would have,
120.
exactly. It would have done us no good to set up the equation 2y equals x plus 5 when we first started, right? Because we don't know what x or y is. There's nothing we can really do there. But now that we know that x is 55 and that angle is 60, we can set up the equation 2y equals 60, which is fairly easy to solve. So be looking for those things too, that as you start to solve the puzzle, other things might become easier or clearer to do. Okay? The two brain busters down at the bottom, let's look at the first one. We're almost out of time. An angle is 3/2 times the measure of its complement. What are the measures of the angles? This is another like, what? Huh? Question. An angle is 3/2 times the measure of its complement. So we've got two angles here, right? And what do we know about those angles? Audrey.
They're going to equal 90 degrees.
Okay, so we know that angle 1 plus angle 2 equals 90. And we know that because we've got that complement there, right? Complementary angles equal 90 degrees. One of those angles is 3/2 times the measure of the other one. So if we label angle 1 just to be x, whatever measure it is, the other angle is going to be
3 times x? Oh,
3/2 times x, right? Or 1.5 times x. You can write it either way. But yeah, right? So since there's an imaginary, I shouldn't say that. Since there's an unwritten 1 here, 1x plus 1.5 or 3/2 x, how many x's do we have in all? Right. So 2.5 x's equals 90. One whole x plus 1.5 x's. So what's the value of x? You're all over this. X equals 36, which means that one angle, our angle 1 that we just labeled x, is 36 degrees. What's 3/2 times 36? 54, which is good news because do 36 and 54 add to be 90? Yes, they do. So the second one, which is all going to be you folks now, an angle is 6 more than twice its supplement. 6 more than twice its supplement. Again, we have angle 1 plus angle 2, only this time they add to equal 180. Like we did in the first one, we'll call angle 1 x, and the other one is 6 more than twice that. You can take it from there. Okay? You can do it. I believe in you. It's a fly. All right, so your homework from the textbook, so I gave it to Blue Group, and they'd be really mad at me if I didn't give it to you too, is going to be on page 39. And this will be due for you next Wednesday. On page 39, let's go. oh boy, 20 through 27. And then 31 through 38. But you already did number 33 because that was in the book, and I put it up there. So you can skip 33 because you already did that one. But so page 39, 20 through 27, 31 to 38. I'm 2 minutes over. I'm disappointed in myself. But that, folks, is how you math.